a study of relationships among weight, fasting glucose and food portion using 3 research methods, including the viscoplastic energy model of the GH method. Math Physical Medicine, number 1207, VMT Sharp 597, January 15, 2025, by Gerald C. EclaireMD Foundation. Category Research Methodology. Abstract. Key message: early morning body weight is closely linked to fasting glucose FPG, which serves as the baseline for post-meal glucose PPG levels throughout the day. Food portions are strongly correlated with PPG, while exercise helps reduce PPG but acts as a secondary factor. Brief description: the close connections among body weight, fasting glucose, and food portion are further validated and demonstrated using 3 distinct research methods: pathophysiology method, qualitative descriptions, the viscoplastic energy method VEM or VMT, based on physical laws, and a preliminary neural network method NNM, a big data-driven numerical method. Viscoplastic energy method VEM, foundation rooted in physics and material science. VEM extends the viscoplastic behavior of materials to biomedical systems, capturing time-dependent, irreversible, and complex interaction dynamics in medical conditions. Relies on physical properties like energy dissipation and system deformation to describe biophysical phenomena, providing insights into chronic or progressive diseases, e.g., diabetes, cardiovascular disease, kidney diseases or cancers. Data requirements requires detailed input parameters grounded in physical or biophysical properties, e.g., stress or influential factor, strain or symptom. Best suited for well-defined biophysical problems, where domain expertise is available. Interpretability: highly interpretable due to its reliance on established physical laws, offering clear connections between lifestyle health inputs and medical outcomes. Applications: ideal for exploring hidden biophysical characteristics in biomedical systems dominated by time-dependent and irreversible processes. Limitations: less effective with complex problems such as intertwining symptoms, or containing noisy subset of database that do not align with its physical assumptions. Implementation of this kind of complications requires significant domain expertise. Neural network method NNM, foundation, based on machine learning and artificial intelligence from computer science. NN models identify relationships between inputs and outputs through statistical pattern recognition, without relying on physical laws. Data requirements: requires large datasets for effective training, prediction and generalization but may overfit when data is limited. Strengths: NNM excels in pattern recognition, prediction, and handling nonlinear, multidimensional datasets. Common applications include medical imaging, e.g., MRI, CT scans, genomics, diagnostic classification, disease prediction, and personalized medicine. Limitations: operates as a black box system, relying on complex algorithms and weights, which limits interpretability and makes understanding underlying mechanisms challenging. Pathophysiological explanations of relationships among weight, FPG, and food portion. 1. Weight and FPG. Excess body weight, particularly from visceral fat, reduces insulin sensitivity, leading to higher fasting plasma glucose FPG levels. Weight reduction improves insulin sensitivity, lowering FPG and overall glucose levels. 2. FPG and food portion. FPG serves as the baseline for daily glucose fluctuations. Larger food portions lead to higher post-meal glucose PPG spikes, which are influenced by the starting FPG level. Proper food portion control helps stabilize both FPG and PPG. 3. Weight and food portion. Increased body weight often disrupts hormonal balance, such as elevated ghrelin hunger hormone and reduced leptin satiety hormone, encouraging larger food portions. Controlling food portion sizes supports weight management, which in turn improves glucose regulation. In summary, by applying the concept of the neural network method NNM alongside some statistical tools and analyzing the author's extensive personal dataset collected from May 15, 2015, to January 15, 2025, a total of 17,625 data points, plus using NNM concept, statistics and VEM tool, the following key observations were made. 1. Patterns in weight versus FPG and weight versus food portion. Both relationships exhibit similar data cloud shapes, skewing upward from the lower left to the upper right corner in a spatial diagram. Within a wider band of ±20%, 98% of the data points are concentrated, while from 84 to 88% are located within a narrower ±10% data band. 2. Outliers beyond ±20%. Approximately 1% of the total data 176 points fall outside the ±20% range, warranting some deeper investigation of their irregularities. These outliers data points located outside these two bands are analogous to identifying suspicious spots or patterns on CT scanned image, using neural networks to assess characteristics such as cancer severity and progression. 3. Viscoplastic energy method findings. VMT energy contributions are 52% from FPG and 48% from food portion. FPG has a slightly stronger connection with weight, significantly influencing diabetes management and overall health. Food portion is more closely linked to PPG, playing a critical role in both weight management and diabetes control. Different research methods offer unique strengths and are suited to specific types of medical problems, providing complementary insights into complex health conditions.